Alex actually reached out to me a couple of months ago about doing a possible talk for 𝘓𝑍Con, and he said that, what about trying out for DEFCON? I said, absolutely. So I'll let Alex take over.
Awesome, thank you. So today I'm going to talk about subdomain takeover, about a cleanup script gone wrong, and a bit about me. My name is Alexander. He, him are my pronouns. I come from New Brunswick. If anyone hasn't been there yet, these are the reversing falls in New Brunswick. It's such an amazing place. And I really want to thank everyone here for welcoming me and let me try out this talk before I present it. This is a rough version of the talk I'm presenting at DEFCON, of Atlantic SecConf, sorry, in April. And I'm a senior software developer who has been working with tech for about 10 years. And my experience is mostly in startups and small and medium-sized companies. And that has allowed me to wear many hats, right? When you are working in a smaller company, sometimes you are the developer, but sometimes you are the sysadmin, sometimes you are the QA, and a lot of times you are the firefighter when there is an incident, right? And you have to learn things on the go. And once upon a time, there was a routine maintenance script that created a security incident. Today, we are going to talk about what happened, why it happened, and what can we all do to prevent it. I'm going to tell a story about automation, gaps, and about how small decisions can compound in ways that can be unexpected. In the agenda today, what we'll cover: how we got here, the incident we faced, the mechanics of it, prevention, detecting, and monitoring. And so I'll talk about the business context, what happened and when, how subdomain takeover works, how to mitigate the risk of this attack, and how to catch if it does happen. And then we close with an open discussion, and I would like to hear whatever you have to add. But first, let's walk through how this whole thing came to be, how we got here. A new portal, a new problem. The setup we had was migrating a legacy site into the cloud. Like, we have this website that was, let's say, productpassport.ca, that was still being used, and we are doing, whole migration to AWS. And the goal is to migrate that traffic gracefully, right? We still want the old URL to work. Like, we don't want to break the internet. An URL that already exists should stay there. And the solution would be to have an S3 redirect bucket. The user would visit productpassport.ca and will be redirected to the new portal, shop.appcheckwizard.com. Of course, these are not like the domains of the incident, but I'm using them for demonstration. With this migration, would have a modern stack, would have CI/CD, would have an automated pipeline. The old domain still had traffic and bookmarks and would be kept alive, and every visit would go to the new portal. Simple, clean, works great, right? And of course it did. Everything worked well for quite some time, until the amplified deployment buckets started hitting AWS bucket limits. And the bucket limit problem is, I don't know how many people here have worked with AWS, but sometimes, great, even when you pay for it, we still have service quotas that we cannot go over, right? And in this case, we had a limit of 10,000 buckets for the whole account. And with every amplified deployment, new buckets are created. So, and for each environment, we are creating new buckets. All deployments create stale buckets, and they start to accumulate. When you hit a limit, the new deployments will fail. So this is a blocker, a production deployment pipeline that's going to be stuck. Okay, we have new code to deploy. The business people want us to ship features. The team needs to deploy, and suddenly there's a hard infrastructure blocking the way. And the engineering team did what had to be done. They built a cleanup script. So we have a simple automated bucket cleanup script where we are checking each bucket if it's empty, if it's old. We are going to remove this bucket. There is a reason for this. We needed to make room. We don't need those stale buckets existing, right? This logic is good, right? Yeah, good. Excellent. The bucket's empty? Yes. Let's remove the amplified leftovers. Is the bucket not modified recently? Yes. Well, the bucket was created about a month ago or whatever. It still exists, not being used. Okay. Is it safe to delete? Nobody checked. The problem is the script had no context beyond what it could see on S3. It only knew about those buckets it was iterating over. It had no idea that we had redirect buckets. And the redirection buckets, they are empty by design. We don't need to hold anything there. They simply exist to redirect a domain. And a good redirection bucket, it's not going to be a recent last modified date. It's not something that we are going to keep updating constantly, right? So a redirection bucket is going to be empty. It's not going to be modified recently. And the script is going to execute on it, and we hit the incident. Timeline of the incident. Day 0, the bucket was deleted by the cleanup script. The DNS is still resolving to our legacy domain, ProgPassport.ca, and whoever accesses it will see a message, no such a bucket, 404. Oh no, yes. Attacker claims the bucket name in their own AWS account. Also no. ProgPassport.ca begins serving attacker content. No automated detection, no alerts fired. Fun. And then yes, 28 days after, we don't know exactly when the attacker claimed the bucket or how long it was live, that the content they put there. Could have been hours, could have been the full 28 days, we don't know. Without monitoring, we don't fail to prevent incidents. We fail to know when they happen. And I want you to think about what this means. It was a legacy corporate subdomain, but anyone visiting that URL saw the content, clients, partners, anyone following the old link. And the only reason we found out was because the client noticed. And once we knew, it was 90 minutes to full resolution. The attack. Please do not do this attack. Do not attempt at home. This is against AWS terms of service. You will probably be banned, okay? If you are a legitimate hacker that are doing pen testing, you need to talk to AWS before you try this kind of thing, okay? Don't try this at home. So I will demonstrate under 2 subdomains that I own and control, because I don't want to be banned from AWS. And the expected behavior, as we mentioned, the legacy site, productpassport.ca, redirect to the new portal, shop.appcheckWizard.com. How do I click this? Sorry. Oh, okay, good. So, sorry about that. First time doing a video on live presentation. So someone visits productpassport.ca and they are redirected to the new portal, shop.appcheckwizard.com, with my legacy website that everyone old enough should be familiar with. Something like this, right? So everything is working. The redirect is clean. Our bucket's there. And then our bucket was deleted, right? 404, no such a bucket there. And after that, what actually happened was someone visit the website, productpassport.ca, and there was a fortune tiger game on the same URL. Connection is secure. Certificate is valid. All those things that we tell people, okay, are you sure the website was not like, I don't know, compromised? Are you sure you are visiting the correct website? Well, everything looks good here, right? What could be going on? So, the actual behavior, not redirect and serving attacker content. That's what the visitors are seeing. Unauthorized and illegal third-party content, because this is a gambling website. Gambling in places that's allowed, it should be certified, should be legit, right? And this is not legit. Hosted under a corporate subdomain and visible to every visitor. This brings risk to the reputation of the company. This puts the company under possible legal exposure, and it can damage user trust. And the thing is, the attacker didn't breach anything. They just filled an empty space that was there. No one was phished, there was no hacking, but they were able to take over our domain. The mechanics of it, and why S3 and any other cloud storage is particularly exposed. The S3 mechanic. We have a bucket matching the CNAME of the target, and what happens with those storages are that bucket names are globally unique across all AWS accounts. So it's not like, okay, I'm going to create a productpassport.ca bucket and then create another one with the same name. That's not what happens, right? And if I delete my bucket, anyone in this room can grab it with the same name. it becomes immediately available, and if the DNS still resolves, we have a dangling CNAME. The attacker's view. So how do attackers do this? It's extremely low effort. The tooling is free, public, and fast. And all what an attacker has to do is to enumerate subdomains, search for the 404 error with no such a bucket message, register the bucket, and profit. Upload the content there, and you have taken over the subdomain. So how do we prevent this? And the real lesson. We have to remember that the script did not intend to do this, right? It had no idea that one of those empty buckets was serving a live domain. It was operating with an incomplete context. It had no idea what it was doing. And it was a combination of automation without proper verification. Automation needs context boundaries, and it does need human checkpoints, right? And this is not unique to automation scripts. With AI agents, if anything that's automated, the same principle applies. We need context boundaries and human checkpoints. So, steps to prevent. Dry mode. Run any deletion script on dry mode first, and human verify the output. Okay? Remember again, the script did not have context of what was deleting, but a human could have. Okay? We are humans, we fail, but that's why we should inspect the buckets, and if we can have a second pair of our eyes on that verification, it's even better, right? Another prevention we can have is like having non-trivial bucket names. Don't make it easy for an attacker to guess the name of the bucket being used for a redirect. You can pseudo-randomize them. You can use a hash, an UUID, or even a timestamp for the bucket name. Well, it's not going to be easy to find that bucket among all other buckets, but still, like trade-offs. Prevention. Block bucket deletion. Document properly the buckets that are being used for redirections, and add a policy blocking any delete attempt. Put a explicit deny on the bucket policy, right? So, to recap the preventive measures. Delete scripts with dry mode and human verification. Use non-trivial bucket names. And block deletion of critical buckets. So, okay, if it happens, how are you going to detect and monitor, right? Because what should have caused this? Like, okay, when you have an incident that could not be avoided, how do we catch to fix it fast? We fixed it in 90 minutes, but it took us 28 days to figure out. So if we had an alert on S3 bucket deletion, if we had health checks on legacy subdomains, if we had uptime monitoring for a legacy subdomain, testing, we did not have any anomaly detection on subdomain content. We didn't know that something else was being served in a site that was working, right? It was detected by a client who reported to us, even though the response time was 90 minutes. A client reporting is not a monitoring strategy. A client should never be your first alert. because that's not a strategy. That's a relationship risk. You don't want to lose a customer over this, right? So even if you have an accidental deletion, if one of those controls existed, maybe the impact would be significantly lower. The deletion was a mistake, but the window of exposure was a monitoring failure, right? And so we are all familiar, I hope, with the Swiss cheese model. Like, we had many layers failing. So I would like to ask, what else would you add? I have told what was wrong in our environment, but we have all worked with different stacks, different organizations, different threat models. What other layers could be added to prevent this incident?
I'll bring the mic over. Oh, here.
Actually, I have a question. I'm wondering why the redirect wasn't done at the registry as opposed to, why did you use a bucket to do that?
Because we were using infrastructure as a code, and everything was done with Terraform, and that's how the redirection was done, right? Thank you for the question.
Stop that. Okay, so you're using Terraform to do it. We actually had this exact same problem at work. So
oh no.
yeah. It's a little worse when you realize how S3 works right now. So if you want to, anyone can try it themselves. Pick like a random string and just do like an NS lookup of a random string dot aws.s3.aws.com, and it'll give you back a 404. So that should teach you, that should teach you how S3 actually works. It will respond to any string, any subdomain that's passed to it as if it's supposed to be valid or not, right? So, and the interesting thing about S3 buckets is that it's a global namespace. So if you know something about AWS, you have regions, you have availability zones and all that stuff. And most things are like tied to a region. So it's like, so your namespace, so a region is best thought of as more of a namespace. So if something's in a particular region, you can duplicate it over into another region with the same name, not S3. So with S3, it's a global namespace. So if you think about what that means, it means someone can register a passport.s3.aws.com or .net or whatever it is. But then now anybody in the world using AWS can't use a bucket named passport.blah, right? That's how these subdomains sort of work, roughly, if you think about it. Now, we actually had the same problem too, partly because when subdomains are created, they're not always under our control. We use Terraform as well, but then someone tears down the bucket and the bucket's supposed to be gone. But what we found out was the Terraform can do a lot of different things all at once. So it could stand up a bucket, it could set up an ELB at the same time. So you create a module, think about as creating a library with all these different functions. So you make a function to make your life easier, which will do step A, B, C, all the way down. So when you create a Terraform module to handle that stuff, so you're not just handling a bucket. If you have something like with CloudFront or something like that, you have DNS. So when you delete a bucket, you should have a module that deletes the bucket and every resource associated with it, which includes DNS names as well. So that was part of the other problem. Now that's particular to S3. How this gets more nefarious is that it could be like, if you think about the IP spaces when you're with a cloud provider, IPs are rotated and they get assigned to a person. So think about someone finds an IP, like a domain, points to an IP eventually on a cloud provider. What if you get assigned that IP after a certain amount of time and they never update their DNS and their DNS always points to this IP? Think about what happens then. That's not a subdomain domain takeover. That's, it's not even a takeover. That's just, I think of takeover as something malicious or something with intent. That's just pure coincidence, right? So on top of that, subdomain takeovers don't just necessarily apply to S3. They can apply to anything under, like, say, SMTP. So even if you're not, like, someone does a S3 bucket, they give you this fake website and stuff, but they can also serve malware from it too, right? So the consequences can potentially be worse than just, oh, I'm redirecting to a legal site or something like that. Suddenly you're serving malware. But now if someone else, you have a subdomain pointing to IBM who does mail services or something like that, suddenly if you have a subdomain pointing to an IP and like to a mail services, this type of takeover can apply to that case as well. So it's not just S3, it's anything that has third-party services. So if you have a domain, you point to somebody for like a service, that is a risk. So.
And in my experience, the worst part is that when you have those domains pointing at other things, is when no one knows those subdomains.
Right.
Like lack of documentation can make things harder to investigate this kind of incident. Like, okay, the client reported this subdomain is serving something strange, but are we even handling this subdomain? We had to start the investigation with that because everyone was so focused on the new portal, that one that was receiving the redirection, that people didn't even remember that the old domain was ours. Okay.
I guess a question is if the cleanup script was for like your software as a service company that touched many clients, or just for this one isolated client?
I'm not going to answer that. I'll answer off YouTube.
Okay. I had other mitigation ideas. Well, one would be, if you're using Terraform, you should sort of, if it's tagging all your objects, tag all your objects to a project, and then have service accounts that can only touch limited projects, or have your S3 policies. So, if you have, even if you have a build program that's going to take up, 9,900, buckets, that's fine. It should never, your build process should never touch your prod buckets, if they're all under one master account. And then probably a front-end load balancer. So all of your inbound web traffic doesn't go to an S3 bucket. And then you can log everything that's supposed to come to you. And then anything that goes to anything else, you either block it if it doesn't come from the load balancer, or at least monitor it so you know anything else that's coming in.
Just something I'm not sure if it was clear, but this was a standalone script, okay? It was not like using Terraform. Well, we had to ship code into production and the deployment was failing, right? The script did make sense, and it was also urgent because we need to unblock production. So that's why, like, we did not go over those steps. So yet another layer of failure, right? We did not go over those steps. Okay, if this is a periodic task, how we'll handle this with our infra? No, let's sort out the production pipeline problem, right? Okay, so I have a takeaway checklist, like what can you do? There's a tool called Can I Take Over XYZ? It's not an add-this, it's an open source tool that's very helpful. You can run against your own subdomains. Please do not do to third parties. And you can verify if you have any 404, no such a bucket. And you can even run this on a schedule to make sure that all the buckets that are supposed to be there are still there. And to prevent, you can have non-trivial bucket names, as we talked. We can block the deletion of critical buckets, and you can run any deletion scripts with dry mode and pair the review of the output. And you can also detect, deploy automated health checks, add smoke testing to the content, and if possible, set CloudTrail alerts on delete bucket events, right? And to wrap it up, a script, it did what it was told to do. That's why we code. We tell the machine and we give a set instructions. It will only do what we say it should be doing, hopefully. You have to build systems that do know what shouldn't do. Even with AI, AI can have trouble figuring this out, mainly without context. They might not verify before it destroys something. And if something is destroyed, you need monitoring to know. So, thank you. And this is my LinkedIn and contacts.
Thank you.